Hello everyone, welcome to my presentation of designing a structure to resist tsunami load. In several decades, there are many tsunami tragedies happened in our world. For example, in Japan in 2010, in Honshu Island, tsunami occurred along this area, and then in 2004, in India Ocean tsunami. It killed about 3 million lives and 186 bridges. So to understand tsunami, we have the four parts. The first one, tsunami energy, and second, tsunami generation, third, tsunami data, and finally, tsunami analysis code. So the tsunami energy. Generally speaking, tsunami is occurred by earthquake, and then the earthquake make the ocean or sea wave and shaking, and then this we call tsunami. And this kind of tsunami involve energies is separated by high speed, impulse force, and generation of height. And then as I speak, the tsunami always occurred by earthquake, but human being is also another reason. In other words, the man-made underwater nuclear explosion also can lead to the tsunami with little or media scale. And during several researches, tsunami involved two types of speed. The first one is high speed, which means the tsunami speed is about 700 kilometers per hour, and then it needs conditions, which is the ocean's depth need to 4 kilometers, and then the low speed is about 30 kilometers per hour, and then the water is less than 30 meters too, and then the tsunami intensity was developed by 3 engineers and scientists, and this formula shown in this picture bottom. And then, according to the U.S. Tsunami Prevent Institution, there are 6 tsunami codes, and then in our researchers, the wave breaking force is quite important one. So the research aim. In this research, we want to rearrange the previous content about the tsunami load, physical performance, and then the analysis bridge with the different beams to resist the tsunami load performance. And the last one, the outline bridge structure under accurate data, which resist the tsunami like Indonesia tsunami happened in 2004. According to the previous study, there are 3 parts in tsunami research: the tsunami ball, tsunami load, and the micro roughness of tsunami load. The first one, tsunami ball. I like to recommend the doctor experiment. This experiment involves 3 parts. The first one is about preparing devices of experiment, which include reservoir, gate, and flume. And the second part, I like to say, the doctor make the tsunami attack on the material with 50 milliliter thickness. And then the last part, there are 55 conducted by 8 wolves slope, and the slope angle has 8 angles. And I like to say this 8 angle represent the real tsunami when it attacked on the bridge deck. And also HDF experiment to check or to analyze the horizontal and the vertical act on a bridge deck, and use the method of SHP method. Tsunami load. It was developed by doctor during several years, and there are two model. The first one is the multi-grid couple tsunami model, and the third one is the finite volume wave model. And the finite volume wave model, there are involved three parts. The first one is the support high flow speed, and the second one is a reserve moment. And the last one produced the tsunami ball. And also the multi-grid couple tsunami model, which means it can compute the relative between the horizontal and the vertical loads on bridge. And then it also can output the module on bridge structure with capacity of damage analysis. Gap. I like to say all the experiments are limitation, and the engineers only research special cases. For example, about the California Super Construction Bridge in 2009. So I like to develop a design. In this design, there are three parts. The first part, the pillar, second deck, and the third cable. In the pillar, this picture shows the cross-section of pillar, and then I'll choose 7 to 10 sample with different diameter from 2.5 to 1.5 meter, and then the experiment module is 1 to 40 scale, sorry. And then the picture shows the deck picture with different beams and the beam spans, but all of them possess the same column, this sample was separated by 4 groups from 144 to 55, and each group act into the pillar groups, and then more importantly it will set other group with different welding method between plate and girder, because the different welding method can change the resist force and resist capacity. So advantage, I like to say, in my design, it can be find the outcome directly, and then it also can saving time because the experimental module through the available data and perform module according to the objective condition. So, and by the way, by contrast, this advantage, there are three parts. The theory, based on the previous theory, this design also cannot get some progress, and then this design cannot break through some thought limitation, because it's quite limited in this area for a researcher. And the last one, experimental environment, is quite simplified than reality. It is common sense that the tsunami is complicated than experiment. So thank you for hearing my presentation.